Hey everyone, welcome back to TechOps tutorial. In this video, we are going to explore something that is essential for working with real-world Kubernetes application, and that's the config map and the secret. These two features help you manage configuration and sensitive data without hard coding anything into your container or YAML files. We will break down what they are, when to use them, and the best practices to follow. This video is the part 1 where we will focus on the concepts. In the next part, we will jump into the hands-on demo with Minikube. So let's get started. Let's start with a simple question. Why do we even need a config map and a secret in the first place? Here's a common real-world scenario. Let's say you have an application running in a Kubernetes and it needs some environment-specific values like env equals to prod. That value might change when you move from development to staging or a production. Hard coding it into your container image, your application code, or even your pod YAML not ideal. It reduces the flexibility and makes your application less portable. So now here is where it gets risky. What if you also need to pass a sensitive information like a database password or a API keys? For example, you can see on my screen db password equals to I have given the password. You definitely don't want that hard coded into your code or stored in GitHub. That's a security risk. So what is the Kubernetes way of solving this? It introduces a clean separation between your application and its configuration using two powerful objects: config maps for non-sensitive configs, secrets for sensitive data like password. This way, your application code stay clean and reusable, and all your config, secure or otherwise, lives outside the container. Let's talk about config maps. A config map in Kubernetes is basically a key value store for non-sensitive configuration. Think of it as a clean way to separate your application settings like a log levels, database URL, or a feature flags from your actual container image. Let's say your application needs something like log level equals to debug and database URL is equals to Postgres URL. Instead of using those values into your container or a pod YAML file, you store them in a config map. This makes your application much more portable and easier to manage across environments. Now, how do you create one? There are two main ways. You can use a YAML as shown in the top right box here. Just define the kind as a config map, give it a name, and add your key value pairs under the data field. Remember, the data field accepts the string data. Or you can create it directly using kubectl. Here is the example. This is the command, or you can create like this. If you have a file with the config values, you can use with /config.properties, or you can use like this. To summarize, config maps are perfect for things like environment variables and generally configuration files that aren't sensitive. We will see how to use them inside a pod a little later in the demo. So let's move to the next slide. Okay, now let's talk about secrets. A secret in a Kubernetes is just like a config map. It's a key value store, but it's specially designed to hold the sensitive data like database password, API token, and TLS certificates, or even SSH keys. Now here are something important. By default, the values in a secret are base 64 encoded, not encrypted. For example, if you run this command echo -n my password followed by base 64, you will get the base 64 string like this, as you can see on my screen. This encoding helps to prevent the accidental exposure, but it's not a real encryption. So you should never treat secrets as a fully secure unless you enable the extra protection. On the right side, here you can see the basic YAML example for the secret. Here we are using obq type, which is the default, and storing the two fields, username and the password. Notice how the values for both are base 64 encoded. Now for security levels, Kubernetes stores secrets as a base 64 by default. You can optionally enable the encryption at rest in etcd, especially in the production. And next, RBAC controls, that's the Kubernetes role-based access control, can be used to restrict who can view or modify the secrets. So overall, secret gives you a structured and centralized way to manage the sensitive data, but just remember a proper access control and encryptions are a key for keeping things safe. So now that we have seen what config map and secrets are, let's quickly compare them side by side. Starting with the purpose, config map are meant for non-sensitive application configuration like environment names, log level or URL. Secrets, on the other hand, are built to store a sensitive data such as password, API token and a private keys. Next is storage format. Config map stores the values as a plain text while the secret use base 64 encoding, but again that's just an encoding, not an encryption. Both config maps and secret can be used inside the pod the same way. You can inject them as an environment variable or mount them as a volumes. Where they are really differ in the security. By default, config map aren't encrypted at rest, but with secret you can enable the encryption at rest in etcd, and it's highly recommended in production. Finally, in terms of visibility, config map are clearly readable in a plain text YAML format. Secret shows up as a base 64 string, so they are slightly more hidden, but still accessible unless the proper access control is in place. Use config maps for general config values and secrets when you are dealing with anything confidential. Let's move to the next slide. Now let's look at how config maps are actually used inside a pod. There are two common ways to use them, as an environment variable or as mounted volumes. Let's start with the first one. You can expose the config map data as an environment variable inside your container. In the YAML example, we are injecting a value for log level and pulling it from a config map named app-config. So when the container starts, it will have an environment variable set like this: log level equals to debug. Simple and clean. The second option is to mount a config map as a volume. This means a Kubernetes takes the key value pair and write them into a file inside the container file system, for example under /etc/config. This is a real useful when your app expect a config files to exist on the disk. Now a quick note about the updates. If you update a config map that's mounted as a volume, the container will eventually see the new data, although not instantly. However, if you are using environment variables, those values are set only once when the pod is created and will not change automatically if the config map is updated. You must delete and recreate the pod to see the new values. The reason of this is that the environment variable are passed to the containers by the kubelet process only once during the initial creation of the pod. A simple restart doesn't trigger this process again. So depending on your use case, File-based config versus environment variables, you can choose the method that fit best. Let's move to the next slide. Just like a config map, secrets can also be injected into a pod in two ways, either as an environment variable or as a mounted volumes. Let's break it down. In the first example, we are injecting a secret called db_password as an environment variable. The values comes from the Kubernetes secret named db-secret, and we are pulling the password key from it. So when the pod runs, your application gets the password, but it's never hard-coded in the YAML. The second method is to mount the secret as a read-only volumes. Kubernetes will create a file, say under /etc/secret/password, and write the secret content into the file. This is great for application that reads credentials from the file system rather than the environment variables. You can also control the file permission using the default mode. Here it is set 0644, meaning it's readable but not writable by the application. A few important security features to note. Secrets are base64 encoded, not encrypted by default, but they can be encrypted at rest if configured. They are often mounted read-only to reduce the risk, and access to them can be tightly controlled using RBAC, role-based access control. So only specific user or a service can read or update them. In short, Kubernetes gives you a flexible and secure way to provide the sensitive data to your workloads without ever using it into your image or a code. Let's go over some important best practice you should always follow when working with ConfigMap and especially with secrets. First, never commit a secret into a Git. This is a common mistake. Secrets are sensitive, so always make sure your .git ignore exclude them. Version controlling credential is a big no in production. Second, encode values properly. When you are creating a secret manually, remember to use base64 encoding, but keep in mind base64 is just a encoding, not encryption. Next, enable the encryption at rest. By default, secrets are only base64 encoded. You can enable the encryption in etcd, which is where the Kubernetes stores the data, to make sure they are protected even if someone gets the access to the storage backend. Then we have RBAC restriction. You should limit access to secrets using role-based access control, so only the right service account or a user can read or update them. And finally, for production environment, consider using external secret manager tools like HashiCorp, Vault, AWS Secret Manager, or Google Secret Manager, integrated with the Kubernetes and provide more advanced features like auto rotation and auto logging. On the right, you will see the security layers, starting from the worst like hard-coded password in a code or a Docker file, to the best, which is a fully integration with external secret manager. Let's move to the next slide. And that's the wrap up for the part 1, the theory behind the config map and secrets. But don't go anywhere. Up next, we have got a hands-on demo for you. In that session, we will create a config map with some application settings, generate a secret for a sensitive data like a password, deploy a pod that use both config map and a secret, and finally, we will validate everything inside the container. All of this will be done using Minikube, so you can easily follow along on your local setup. If you found this explanation helpful, make sure to hit the subscribe and turn on the bell icon so you don't miss the practical part. Thanks for watching TechOps tutorial. where we make a Kubernetes easy to understand.